Welcome to aminacademy.com. In statistics and econometrics, let us discuss about measure of dispersion. Dispersion in statistics. Dispersion in statistics is a way of describing how to spread out a set of data is. Dispersion is the state of data getting dispersed, staged, or spread out in different categories. It involves finding the size of distribution values that are expected the set of from the set of data for the specific variable. The meaning of dispersion in statistics is numeric data that is likely to vary at any instance of average values. Now let us discuss further about more about dispersions. Dispersion of data in statistics helps one to easily understand the data set by classifying them into their own specific dispersion criteria like variance, standard deviation, and ranging like. Dispersion is a set of measure of helps to one to determine the quality of data in an objectively quantifiable manner. Most often, data science courses starts with the basics of statistics, and dispersion is one such concept that you cannot afford to skip. Measure of dispersion. The measure of dispersion contains almost the same unit as the quantity being measured. There are many measures of dispersion found that help us to get more insight into the data. Range, variance, standard deviation, skewness, interquartile range. These are some measure of dispersions. Types of measure of dispersion. The measure of dispersion in statistics is divided into two main categories and offer way of measuring the diverse nature of data. It is mainly used in biological statistics. We can easily classify them by the checking whether they contain units or not. Also, measure of dispersion is very useful in econometrics. We can divide the data into two categories, which are absolute measure of dispersion and relative measure of dispersion. Two type of dispersion is absolute measure of dispersion and relative measure of dispersion. What is absolute measure of dispersion? Absolute measure of dispersion is one with units. It has the same unit as the initial data set. Absolute measure of dispersion is expressed in terms of the average of the dispersion quantities like standard or mean deviation. The absolute measure of dispersion can be expressed in units such as rupees, dollars, centimeters, marks, kilograms, and other quantities that are measured depending on the situation. Types of absolute dispersion, measure of dispersion in statistics is range. First is the range. Range is the measure of the difference between the largest and smallest value of data variability. The range is the simplest form of measure of dispersion. Here there are 1, 2, 3, 4, 5, 6, 7 is there. Range is largest is 7, smallest is 1, subtraction is 6. So range is 6. Mean. The mean is calculated here. We'll use one more number here for now. Your range is 8 minus 1. 8 minus 1 equal to 7. Now mean, mu. Mean is calculated as the average of the numbers. We know that. To calculate the mean, add all outcomes and then divide it with the total number of numbers. That means here 1 to 8 the numbers are given. You have to find the mean, means add them and divide by 8. So add is sum is 36 divided by 8 is 4.5 is our mean. Now from this we can calculate variance. How to calculate variance? First make a table like x is given 1, 2, 3, 4, 5, 6 up to 8. Then difference. Difference means each variables, each quantity varies, how much varies from the mean. So here d equal to x minus mu. That means 1 minus mu is here 4.5. 1 minus 4.5 is minus 3.5. 2 minus 4.5 is minus 2.5. Like that you have to write up to 8. That is 8 minus 4.5 is 3.5. Now square the deviations. Square the deviations is d square you have to find. So minus 3.5 square is 12.25. Minus 2.5 is 6.25. All are in positives. Add them, it gives 42. Now variance, how to calculate? The variance is sigma square. In simple terms, the variance can be calculated by obtaining the sum of the squared distance of each term in the distribution from the mean and then dividing this by the total number of the terms in the distribution. Here the formula is sigma square equal, which is equal sigma x minus mu. First the square is there, is 42 divided by 8, which is equal 5 8s are 40 and 2 20, 2 8s are 16 and 5 8s are 40. Here then formula variance is sigma square is 5.25, then standard deviation is square root of 5.25, which gives let us calculate square root of 5.25 is approximately 2.29. Is a standard deviation of this dispersion. Next one, we'll talk about quartile. Quartiles divides the list of numbers or data into quarters. That means 4 quarters. Here, quartile deviation. Quartile deviation is the measure of difference between the upper and lower quartile. This measures the deviation is also known as the interquartile range. Here, I will take the same example. 1, 2, 3, 4, 5, 6, 7, 8. We have to split first 2 sets and 7 2 sets. In between this we have to find median of this one is 1, 2, 3, 4. That is which is therefore Q1 lower quartile is 2 plus 3 by 2 is equal, that is the median of first half set equal to 5 by 2 is 2.5, and but the second is, that is Q3 is 5 6 7 plus 8, 5 6 7 plus 8, middle is 6 plus 7, that is 6 plus 7 is 13, 6 plus 7 by 2, 13 by 2 is 6.5. Therefore, interquartile range is Q3 minus Q1, that is 6.5 minus 2.5, which is equal to 4. This is interquartile range of this dispersion. What is mean deviation? Mean deviation is also known as an average deviation. Its mean be computed using the mean or median of the data. Mean deviation is represented as the arithmetic deviation of a different items that follows the central tendency. Here the formula as mentioned, the mean deviation can be calculated using mean and median. Mean deviation using mean is sigma x minus mean, absolute value of x minus mean divided by n. Mean deviation using the median is sigma absolute value of x minus median divided by n. N is the total number of items. Here you have to use the absolute values. We can do this problem as yourself, as the dispersion is 1, 2, 3, 4, 5, 6, 7, 8 also. For that also we can find these values. Relative measure of dispersion. Relative measure of dispersion in statistics are the value without units. A relative measure of dispersion is used to compare the distribution of two or more data sets. The definition of the relative measure of dispersion is the same as the absolute measure of dispersion. The only difference is the measuring quantity. The type of relative measures of dispersion. Relative measures of dispersion is the calculation of coefficient of dispersion where two series are compared, which differ widely in their average. The main use of coefficient of dispersion is when two series with different measures units are compared. Now, first one, the coefficient of range. It is calculated as the ratio of difference between the largest and smallest terms of the distribution to the sum of the largest and smallest terms of the distribution. For that, here the dispersion is 1, 2, 3, 4, 5, 6, 7, 8. Suppose L minus S, lower L minus S by L plus S. Largest is 8 minus smallest is 1 divided by largest 8 plus 1, which is equal to 7 over 9 is the coefficient of the range. Coefficient of range is, we can find 7 minus 0.7 is 63, that is then like it goes like this. It's 0.777 is the coefficient of range. The coefficient of variation. The coefficient of variation is used to compare the two data with this respect to homogeneity or consistency. Formula coefficient of variation is sigma by x into 100. Here sigma is standard deviation, x is a standard deviation, sigma is a mean. So if you use this formula, we can find the value of coefficient of variation. Next is the coefficient of standard deviation. Coefficient of standard deviation. The coefficient of standard deviation is the ratio of the standard deviation with the mean and distribution of terms. Like here, the sigma is square root of x minus x1 by n minus 1. Deviation is x minus x1, and sigma is standard deviation, and n is a total number. By using these values, we can find the coefficient of standard deviation. Next, the coefficient of quartile deviation. The coefficient of quartile deviation is the ratio of the difference between the upper quartile and the lower quartile to the sum of the upper and lower quartile. That is Q3 minus Q1 and divided by Q3 plus Q1. Already we have quartile, lower quartile and upper quartile. If you use that values, we can get this coefficient of quartile deviation. The coefficient of mean deviation. The coefficient of mean deviation can be computed using the mean or median. Mean deviation using mean is already done. Sigma modulus of x minus m mean divided by n by using median is here. Dispersion is important in statistics. The knowledge of dispersion is vital in the understanding of statistics. It helps to understand concepts like the diversification of data, how the data is spread, how it is maintained, and maintaining the data over the central value of central tendency. Moreover, dispersion in statistics and econometrics provide us with a way to get better insight into data distribution. How to represent dispersion in statistics? Dispersion in statistics can be represented in the form of graphs and pie charts. Some of the different ways used include dot plots, box plots, stems, leaf plots like. These are the graphical representation of data dispersion. Some statistical ways to measure is, we know that standard deviation always explained, range, mean absolute difference, median absolute deviation, interquartile range, average dispersion. Finally, the dispersion in statistics refers to the measure of the variability of data or terms. Such variability may give random measurement errors where some of the instrumental measurements are found to be imprecise. So far, we explained about dispersion in different categories. We have done. Please subscribe our YouTube channel.